Welcome. We're still working on our data management unit 4. So that's great. We're going to spend a little bit of time on this, the concepts in this lesson 17 because they cover a lot of stuff. We'll go over that. I'll do a little bit of a review from yesterday. What we were looking at yesterday was ways of taking a pile of data and sort of getting an idea of what it's like. Right now, if somebody's making a soup or a stew, they might taste it, right? They don't have to eat the whole thing, right? They just taste it. That gives them a little idea, too much salt, not enough, whatever. And that's what we're doing with some of these measures of central tendencies. We're just getting a little taste of our data to see what we have. Okay, it can tell us some things. We really are just looking at the technical aspect of this in this lesson, not really the why we would want to use this. We'll get a little bit of that in the next lesson, but basically we're just going to learn how to do it, how to test a pile of data. So the first one we looked at yesterday was the mean, and the mean is also known as the average. And I think that you may have seen averages before. What you do to find the average or the mean is you add up all the values in the set of data, and then you divide by the number of values in the set. Right. So if you have 5 items, you're going to add them all up and divide by 5, and that gives you the average. Okay, and that's if you've been following, in school or something, you've been following your quizzes or something like that. That's how you find out how you're doing, right? You basically get your average. You add up all your marks, divide by the number of quizzes, and that's it, right? So that's the mean. Okay. So that sort of gives us an idea of how it'll work. And if you have a few zeros in a set of say test scores or something, it's going to move the mean a little bit more towards those zeros. If you have a bunch of 10s in a bunch of test scores, say out of 0 to 10, it's going to move the mean a little bit more towards the 10, right? So that's how the mean kind of works. It gives you a little bit of a sense of what the expected performance would be. Okay. Now, the median is another measure that we use, and median, if you think of the median on a highway, that's the middle of the highway, right? You're not allowed to park on the median, right? If the police want to set up, they want to chase after you, they're gonna park in the median there. So the median really means the middle, and in data analysis, what we want to do is organize the data in numerical order. This is really important. So you're going to rank them from low to high, and then you're going to count the number of them and basically count to the middle single value if it's an odd number of values in the set, or the middle 2 if it's an even number of values in a set. Okay, once you find that if it's odd and there's a single number, then you're done. If it's even and there are 2 numbers, then you have to find the average or the mean of those 2 numbers. You just add them together and divide by 2. Okay, so that's how we find the median. And then the last measure of central tendency that we looked at is the mode. Now, the mode is just the most frequent value, right? The most often repeated value. So, for example, if you're writing quizzes and you get a lot of 10s, and then you get a few other, an 8, a 9, or whatever, the mode might be 10, right? That's really the most frequent. So if your teacher's looking at that and says, oh, okay, this student is getting mostly 10s, that's the mode, right, of the data. And then, maybe they got a 9, maybe they got an 8, they forgot to study or something like that. And so then, but that's not the typical performance, right? Whereas if you took the mean, you'd be getting more of an average, which would still be pretty close to 10, but it wouldn't be quite 10, right? So there you go. So the mode is then you can sort it. That's the easiest way to do it. Sort it by in numerical order from low to high, and then what you'll find is that there are groups of repeated numbers usually. Okay, and you'll find the group of numbers that's repeated the most often, and that's your mode. Now, if it's a single value that's repeated, as in example 3a there on page 9, you'll see that there's only one mode. The sevens are repeated, and there are no other values repeated. Sometimes you'll have two sets of values repeated the same number of times or more than two, and then it's going to have multiple modes. So the data can have more than one mode, right? So how does that happen? Well, if it probably wouldn't, it could happen, for example, if you're looking at your marks, right, and you got a bunch of 5 out of 10s, and then you got a bunch of 10 out of 10s, right? You could actually have two modes. Well, what would that tell your teacher? Right? It would tell your teacher that you had mastered some of the material, but you were still struggling with the ones where you're getting a bunch of 5s, right? It's not a fluke that you got some 5s. If you got a bunch of them and it's enough to make it a mode, then it means you need some help in that area. So there are some things that we can use, some ways that we can use this, and we don't have to do a lot of analysis. It's a pretty simple thing to do, right? You just rank them in order, and then circle the most frequent repeated numbers. So it gives us a really quick taste of what we have in the data. Now, yesterday I said I was going to do a few, because I skipped over the median a little bit, doing the support questions for the median. So let's take a look at that. This is the top of page 9. And they have some practice questions there. So let's take a look at those. I'm going to, just because I'm going to go to a fresh page here. Actually, let's see. Did I actually do? No. Okay. So, so top of page 9, um, the median. Okay, median average. So let's take a look at the first one. So the procedure then, this is a support question 2. This is page 9. And so the first one, it says calculate the median average for each set of numbers. So A, I'll just write out the numbers here: 3, 6, 2, 7, 3, 5, 8. So the first step to calculate the median is, and now remember, the median and the mode, you're really going to need them sorted in order. So chances are it's probably a good idea just to sort them. Now the way I do this, I'm going to go through. The smallest number is 2, then the next one's 3, and then there's another 3 there. There's no 4, but we do have a 5, a 6, a 7, whoop, do that as a 7, and an 8. There we are. Okay, so that's our data sorted. And let's just check 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Perfect. So there's 7 items, which means the middle one is going to be there. It's 3 on each side, right? Or you could just divide 7 by 2 to find the middle, and what you end up with is 6.5. So, or sorry, you end up with 3.5, which means that it's 3. You have to skip 3, and then the 0.5 is that little middle number that you're looking for. So to answer the question then, the median in this case is equal to 5. Now you notice that it doesn't really tell you anything about like the average. If we took the average of these numbers, the average would be, I think, maybe a little lower than 5, because there's so many low numbers in there. Well, maybe close to 5. So the median just kind of gives you an idea of what the middle of a range of numbers is. Okay. All right. So that was, and then if we had to do one that had an even number, we could do something like B here. B. Okay, so that's going to be 23, 28, 32, 15, 28. Normally you would just you'd cut and paste these into your Word, into your Excel or something like that, rather than try to write them out. So understand that while you're studying and you're learning how to do this, there's a little bit of work you have to do by hand. The fact is that you really will be able to just cut and paste these normally. You normally use computers and tools and stuff like that. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, okay. Well, okay, this one is also has a it's going to have a single middle number. I don't know why they gave us two examples the same, but let's take a look, because the range of values is a little different. What's the lowest? I think 12 is the lowest. All right, so it's going to be 12. Okay, and then 15 is almost like the lottery numbers. 15, what's the next one? 23, I think. 23. Okay, what's next? 28. 28. 29. Oh, no, there was another 28 there. Let me fix that. Oh, okay, that's not what I wanted to do. All right, we'll try this. Okay. Another 28. Then the 29. Okay. 32, 32, 32, 32, 32, and 35. Okay, and I'll just double check that we have 9. Yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so it's just a little quality control check, make sure that I didn't forget one. So there's 9, which means that we're going to have, we take 9 divided by 2, we have 4 in a little bit. So that means that we need to count 4 in each direction. Okay, and then there's our middle number. So look at that. That is our median. I'm just going to extend the page here to get a little more room. So our median, whoa. Our median is 28. All right. So, and I think we can sort of look at this C here. If there's an even number of elements, then basically you would take the middle two. Let's say, and I don't just sort of guessing here. Let's say that it turned out to be let's say it turned out to be 84 and 88. I don't really know for sure, but if those were your middle two, then your median is just the average, really. Median. All right, I get this. Median, M-E-D-I-A-N. So it'd just be the two numbers added together, divided by 2. And this is just an example. Okay, I'm not really sure what the middle two numbers are. We'd have to write down all those numbers and then arrange them in numerical order. So, okay, so that was our median. We did some mode questions the last time, and I think that should be all right. Let's take a look here at what we got for some mode questions. Okay, the mode. Did we do some of those already? No, we didn't. Okay, so calculate the mode. I don't know why they keep saying average here. It's just the mode. That's what people are going to ask you to calculate, the mode, not the mode average, for each set of numbers. So let's take a look at this one right here. Again, it's a little easier to just rank them. So 2, 3, 3 in numerical order. 2, 3, 3, and 5, 6, and 8. 5, 6, and 8. So there's our list in numerical order, and I can see that we have just one repeated value, which is 3. So in this case, then the mode is 3. Okay. Now you might think, well, I can go along and I can pick out the ones. maybe you could, but it's there's a little risk to it, and besides, you're going to need them sorted for some of the other things that we do. Anyway, if you were asked for the mean, or sorry, the median, you would need them sorted too. Okay, so it's worth it just to rewrite them. As I say, this is just for the purposes of the course. Certainly, if you had a job doing this, you'd be using some tools and probably just cut and paste them into a spreadsheet and push a button and they'd be sorted for you. Okay. Now, the next little bit is, so we've taken a look at the so-called measures of central tendency, and those are the three different things that we're looking at. Okay. And you can think of them if you're going to, your Kukum's making a stew, right? What are her measures of quality of the stew? She stirs it to see if it's thick enough. If it's not thick enough, maybe she'll add some stuff. She tastes it to make sure it's got enough, um, you know, sauce in there, and she might kind of stir it up and look to make sure that there's enough vegetables to meet ratio. So those are three measures that she makes to figure out if a stew is good without having to eat the whole thing, without having to serve it to everyone. Just a quick test to see what she's got. Well, that's what we're doing with our data, right? We're finding the mean, we're finding the median, and we're finding the mode, and those are just ways that will tell us something about the data without having to really graph it or do a lot of other stuff with it. Okay. Well, sometimes we need to know a little bit more detail. And again, these calculations are all pretty standard for a spreadsheet like Excel. As a matter of fact, Excel's, this is what really Excel is for. Someone sitting there one day trying to work these out by hand going, there's got to be a better way. And Excel is the answer to that. So there are three things that we calculate here: standard deviation, variance, and range. And I will tell you that the one, the standard deviation looks a little complicated. It's really not. It looks complicated, but we'll go through it. We'll do some examples. But variance and range are pretty straightforward. So that's. But yeah, don't just take a look at this standard deviation. It's actually not so bad. So standard deviation is a measure of the extent to which data cluster around the mean. So if I have a what's called a standard distribution. So you've heard of the bell curve, right? So it's shaped like that on the side. And generally speaking, that peak will be the mean, generally. Okay. So you may have seen this before if we're talking about marks, in math class or something like this. This is how we expect the marks to look. Now, here's the thing. If this is 0 and this is 100, that's actually not the way we expect the marks to look in math class. I don't think too many students would be happy if the class average was 50, right? In fact, the marks are actually going to be skewed in math class towards the higher marks. Like, the average might be 70 or 75, a couple of keeners, and they're 80 or 100 even. And then a few students, maybe they missed a few days or something, and they're going to be getting some lower marks. Okay, so even though this is what we expect a sort of a standard distribution to look like, there are a lot of things that won't be quite like that. We're going to have a look at that in the next lesson, and actually the shape of the curve and where it's positioned tells us quite a bit about the data. Okay. As a matter of fact, in a lot of math classes, really, the data would almost look like that, sort of like that, where most people actually get a fairly decent mark, and quite a few of them even get close to the perfect, right? And then a few have some problems down at this end. And part of that is because teachers collect data, right? They monitor what's going on, and so if somebody is struggling, then they'll help them, and then that tends to kind of push the mean, and it tends to push all of the data closer to 100%. right? Because if a student does poorly on a quiz, the teacher sits and works with them and maybe gives them a quiz again, and then they do better. So it does tend to be kind of not shaped in a standard distribution. All right, let's take a look at how we measure. Okay, so well, we talked about standard deviation. So that's the extent to which a data clusters around the mean. Let me kind of try and draw a little more illustrative diagram here. So I was just showing you the standard distribution for data, but what if we had the data that was like really spread out like that versus a curve where the data was really sort of clumped right around, right, around the mean. Those two shapes tell us something about the data, right? For example, with the one where everything's spread way out, what it means is that when we find the mean here, that doesn't really tell us what the data looks like, right? That the typical data, there's values all over the possible range of data, right? So it tells us that the mean might be a little misleading, right? The standard deviation, right? But if the standard deviation, if the data is distributed fairly close to the mean, then it tells us that the quality of our measurements is probably pretty good, the quality of our data, and it tells us that the mean is a good representation of the data. Okay, so those are some things that we'll look at. And if you're going on and actually taking a whole class on statistics, you're going to learn a whole lot more about this and exactly how we look at these data sets and all the different tools that we use. Okay. And range is just the difference between the highest and lowest. So the range is just the measurement of this. And again, the higher, the bigger the range of data, it gives us some hint about what our data looks like. Okay. So if I have quiz marks from a quiz and it's scored out of 10, but the range of my data is only 5, that tells me that everyone's doing pretty close to the same on those quizzes. See? All right. So we're going to calculate. The first thing we're going to calculate is the variance. Let's see here. Okay. Okay. So whenever you're asked to calculate the variance, the standard deviation, and the range, you're going to be given a table like this. Okay. And the table will be your values. Okay. And well, that's about it. The rest of it's all been filled in. So you'll be given your values, and it doesn't really matter for our purposes whether they're sorted in order or not, because we're just doing some calculations. Okay. So the first thing that we're going to do, so pretend that this column and this column and this column are empty, because that's what you'll find when you're actually doing this kind of assignment. Okay. So the first step then to find the variance. Okay. So this is the first step that we're going to do, is the variance. Okay. And once you have the variance, we use it to find a standard deviation. Okay. So the variance then is it's the sum of the squares of. All right, let's just back up a little bit. So we have all these pledge amounts. So the first thing we want to know is the mean. Okay. So the mean is the sum of all of these values divided by the number of values. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in this case, here's 10. And we just sum all those values. And I'll just do it. I don't have to write it all out. It's just, it's 2 plus 3 plus 4 plus 4 again, plus 5 plus 5 plus 6 plus 6 plus 7 plus 8. So that gives me 50. Okay. And so that means that my mean is 5. Okay. So that's what I've done. I've found my mean. Now, they put a whole column for the mean here, and then they filled it in 5 all the way down. In fact, once you know the mean, you can go right to calculating this column right here, which is the value minus the mean. What you're calculating there is the difference of each value from the mean. So if we have a data distribution here, whoa, okay, that's terrible. That's terrible. If we have a data distribution, and this is the mean, okay, and we have a data point right here, what this column's difference from the mean calculates is this length right here, the difference between the mean and the actual value. Okay, so what we're doing is we're making a table of values of differences, okay, which gives us some insight into how big this spread is. Whoop, and I just erased some of it. There we go. Okay, so in this case, so it's the value minus the mean. It's negative numbers. Don't worry about the negative numbers, and I'll show you why in a second. We're not interested in the sign of the number. We're just interested in the magnitude of the number, because the distances, right, between the mean and the values, we just want to know how far it is, not whether it's positive or negative. Okay, we don't really care. All right, so in this case, 3 minus 2, so 8, for example, 8 minus 5 is 3. So you can see that there's going to be a range of positive or negative values. Now the next thing we do is we simply take the square of these numbers here, and this is why the sign doesn't matter, because when you square a number, the sign goes away. When you square a number, it becomes positive, no matter how it started. Okay. So, and that's a common tool in mathematics that we use. We square a number and then we don't have to deal with the sign. Okay, there's other ways we can do it, but that's an easy way to do it. Okay. So we're going to square negative 2, we get a 4, square negative 1, we get 1, and of course 0 squared is 0. A lot of these you could probably do in your head. So I hope that I've shown you that even though it looks pretty complicated, that really it's a matter of calculating the mean and just doing some subtractions of the value, and then you subtract the mean from the value to produce a difference, and then you square that number in the next column. So it's just a matter of going through all the data and coming up with the squares of the differences. Now what you're going to do is you're going to add up all of those squares of the differences, and what this is the sum of the squares of the differences. And now we're ready to calculate the variance. And the way the variance works is the variance, which actually has a, which is called S squared. That's a symbol for it. Because, for example, the mean, we call it X with a bar over it. The variance, which is known as little s squared. And basically, it is the sum of the squares of the differences. So in this case, it's 30 minus the number of values in the set minus 1. Be careful here. Okay, so we know that there's 10 items in this set, but 10 minus 1 is 9. Okay, so this is the sum of the squares of the differences. Squares of differences. Okay. Divided by n minus 1, which is the number of items in a set, minus 1. Okay, I got to extend the page here. So our s squared, then, our variance, is just going to be 30 divided by 9. Okay, and you can do that in your calculator. It's 3.3 repeating over that. Okay. And that's it, 3.3 repeating. So what that is a measure of is how far away the data is from the mean. The better the data, the smaller that variance, basically. Okay. All right, well, once we have the variance, then the next one is really simple, okay? Because the next one is the standard deviation. Whoops. Okay, so standard deviation is just the square root of the variance. Which is the square root of s squared, which in this case is the square root of our 3.3 repeating. So if you still have that number on your calculator, you don't have to re-enter it. You just hit the square root button. Okay. And 1.8, something like that. Okay, now they gave it to 2 decimal places. It's pretty hard to justify given that they were all whole numbers here. So anyway. Let's see, the range of the data. So the range is just the smallest, the difference between the smallest and the lowest. Okay, and it's going to be a positive number. Okay, so it's just the difference between the smallest and the lowest. So in this case, having everything sorted in order really helps us because we have the largest and the smallest. So 8 and 2, so 8 minus 2. Okay, let's go all the way down here. So it's 8 minus 2 equals 6. And none of these numbers have units because they're unitless. They're just sort of like yeah, they just don't have units. Okay, so there we are. So we've worked out then the variance, which was the one that was, it took a little bit of calculating. We had to make a table of all of the values. Then we found the mean, which in the text it puts it in the table. You really don't need to because it's the same for each column, but you do need it to calculate the difference. Right, so we calculate the differences and then we square the differences. And again, you know, if once you're used to doing this, you probably could do that all in one step and just have the square of the differences in the table. So you get your square of the differences, and then you're going to find the variance by taking the sum, the total of the squares of the differences, divided by the number of items in your data set, in your table, minus 1. And I can't emphasize that enough. That's a bit of an oddball because we use n for the mean, but we use n minus 1 for the variance. Okay, and there's good reasons for it, and there's actually cases where we don't. But if you're curious at all about why that works like that, then you can take a statistics class when you get to college, and it'll tell you all about it. I've taken that statistics class. It's very interesting, and you'll never look at a statistic the same way again in the news, especially, or when politicians or in advertising or anything. It really opens your eyes. So. Standard deviation is just a square root of the variance, which is s squared in this case. So once we have our s squared, we just take the square root of it, 1.8. And a range is just the difference between the largest and the smallest number. It's always going to be positive. Okay. So that's it. It seems maybe it's a bit more complicated than it is, but just practicing some of these will really help. So question 5, support question 5, they ask us to do that calculation. So let's do that. We'll do that together. And you can see the key question 17 is relatively short, but it's because they're asking you to find the variance, standard deviation, and range for a couple of sets of data. So that's going to have That's going to take a little bit of time. All right, so this is support question. Oh, yeah. Support question 5. That's on page 11. Okay, page 11. And so the first one's going to be maybe a little easier for us. Calculate the variance. So this is A. It's a little shorter. It's 3, 6, 2, 7, 3, 5, and 8. I think that's got it. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Yep, so there's 7 items. Okay, so we're just going to put the value here. Okay, the value. Now, as they say, the mean, the way they do it in the book is you put the mean, and then we put the difference, and then we put the square of the difference. You could actually write it, difference squared if you want. You can put that there. Okay. All right, so that's our table, and we're going to need, what did I say, 7? We're going to need 7 rows here, plus the total. There's 2, 3, 4, 5, 6, 7, and then there's that row for the total down on the other side. Did I? Yeah. Oh, look, it worked. It's great. Okay. So we set up our table. As far as I know, if you're asked to use, I'll check. If you're asked to use on an exam, I think they give you the table, but I'm not positive. I'll have to check that. But anyway, you'll know how to do this. So you're just going to put the values in. Now we have a choice. We can put them in. We don't need them in sorted. So let's not bother sorting them. Let's not make things harder than they need to be. 7. Now if they'd asked us for the mean and the mode and stuff like that, then we probably would if the median and the mode, we would have to sort them. Okay, so we have the value. Now we need to find out the mean for this value, for these values. So we're gonna work that out. So x, the mean, it's going to be the sum of all of those divided by 1, 2, 3, 4, 5, 6, 7. Okay. Now instead of writing them out in some big addition formula, just plug them into your calculator. 3 plus 6 plus 2 plus 7 plus 3 plus 5 plus 8. There we go. So we got 34. There we go. 34. Okay. And so 34 divided by 7, I get 4.9, I guess is what it's going to be. I'm going to double check that. 2, 3, 4, 5, 6, 7. Okay. All right. So 8 plus 5. I'm just doing it backwards. 3, 7, 2, plus 6 plus 3. Yeah, still 34. Okay, so our mean is basically 4. Let's call it, 4.86. Let's call it 4.86. I sort of hesitate to put any more accuracy than that, but I think that'll probably be fine. So it's going to be 4.86 all the way down. Okay. All right. So 3 minus 4.86 minus 1.86. Now, you know what? Do yourself a favor, and at this point, hit the square button on your calculator. 3 point, let's just round this to 1 decimal place. Okay, so there you go. So for the next one, it's 6 minus 4.86. So it's 1.14, and hit the square button right away. Whoops. And it's going to be 1.3. Okay. And so 2 minus 4.86, negative 2.86. And again, we hit the square button and it's going to be 8.2. Okay, I'm just rounding to one decimal place. So 7 minus 4.86. Now, one advantage to putting them in order is it'll be more obvious when you have duplicates, where you can take a little shortcut. So for example, 3, I don't have to recalculate that. It's already there. I'm assuming that I got it right the first time. Okay, so it just saved me a little bit of effort. 5 minus 4.86, so 0.14. Okay, we'll square that, and I got 0. Really, to round to one decimal place, it's 0. Yep, pretty small number. And then 8 minus 4.86, and we get 3.14. Square that, and 9.9. Okay, so far so good. Now, remember that we want to sum these up, so we'll write that as the sum. So we're going to sum all those values in the square of the differences. So 3.5 plus 1.3 plus 8.2 plus 4.6 plus 5 plus 0 plus 9.9, and we got 31. Okay. All right. So we got the mean right here. The variance, which is s squared, is equal to the sum divided by the number of items minus 1. Okay. Don't forget that. And so it's going to be 5.2. And I still have that number in the in my calculator. Standard deviation is equal to this square root of s. In this case, I'm going to extend the page. It's a square root of, it's 5.2, but I still have a number in my calculator, so I'm just going to take that. That's a little bit more accurate. Oh, what did I just, okay. And that's going to be 2.3. There you go. So those are the answers, and that's what they're asking you for. Okay. Now we could let's see, let's take a look. Oh yeah, and the range. Okay, so the range is 8. 8 is the largest and 2 is the smallest. Yeah, so it's 8 minus 2. Okay, so that's 6. Okay, so those are our values there. Now we can look and we can see the answer. If you want to check the answer at the back, you can see how they did it. Now they put it to a fairly large number of decimal places, 2 decimal places. As long as I'm marking your work, I will accept 1 decimal place for all your final answers anyway. You notice that I tend to keep 2 decimal places in the in these calculations, but then once we get over here, there's really no point. Our answer, if we rounded off what we got compared to what they got, I think we'd be pretty close. What did they get for a standard deviation? I got 2.3. If you rounded theirs off to 1 decimal place, you'd also get 2.3. So basically carrying all of their answers to 4 decimal places as they didn't do them any good. All right. So that's, anyway, they probably did that on a spreadsheet or something in the text. So that's how you do them. There's a couple more practices that are a little longer, so you can work on those, do some of them, compare your answers to the ones in the back of the book. Now you have to do the whole thing in order for you to find the variance and the standard deviation. But it's probably a good exercise to do number 3B, and make sure that you understand it before you spend a lot of time doing the key question. Uh, the key question. Okay. Now, uh, let's take a look at these key questions. I don't think there's any. Oh, sorry, I said 3. I was looking at the wrong page. I meant uh, B. 5B. Yes. So they're asking you to do the same thing, which is a slightly larger set of data. All right, well, let's take a look at the key questions, and then we wrap it up here. So the first one, the key question, we're going to do the mean, the median, and the mode for each set of numbers. So I think your strategy here almost certainly going to be to sort them in numerical order. You can add them up, divide by the number of items in the set. That's your mean. Your median is your middle number, or the average of your middle numbers, middle two numbers if it's an even set, and then your mode, your most frequently seen value, and that's where sorting it will really help you. Okay, maybe there's one mode. Now, if there are no repeated values, it means there is no mode, and you just say that, no mode. Okay, so something to kind of keep in mind, because I don't think they really talked about that. They kind of blew past the whole concept of mode in the text. But they didn't talk about multi-modes, and they didn't talk about no modes. But yet I know, I think some of these have no mode in the data set. All right. So, and then you're asked to calculate the variance, standard deviation, and range. So by now you've seen a couple of examples of how to do that. So you just make yourself a table, right? You make yourself a table with the values, right? The values. If you want, you can put the mean in there. If you don't want, you can skip that whole thing, and then that's fine, right? You just calculate the mean and write it down separately. The difference, and then of course the difference squared, which I just ran out of room. Difference squared over there. So you'll work that all out and just follow the steps in the text, and you'll be fine. Remembering that when you're calculating the sum, when you're calculating the variance, the sum of the differences, the squares of the differences, divided by the number of values in the set minus 1. Just one of those oddball things you're going to have to memorize. Okay. And then finally here, question 3, without calculating, predict which data set will have the largest standard deviation, okay, and which will have the smallest. Okay, now this is tricky because to have a good idea, they don't explain how to do this in the text. Okay, so what I'm sort of interested in is see what you come up with. Okay, like how can you tell the standard deviation? Remember that the standard deviation measures how far that the data is from the mean. Okay, so it basically, your standard deviation gives you this value here, and what does it mean for the data if the values tend to be a little closer to the mean? Okay, and even if you don't know what the mean is, right, like if you don't calculate the mean, you can still take a look at the data, and you might be able to kind of get an idea of where the mean might be. Or maybe you do have to calculate the mean to kind of give yourself an idea, right? So, but that's the standard deviation is this width here, basically. Well, actually it's half of it, but you get the idea. It's how far away the data tends to be from the mean. All right, so that's your assignment there. So yeah, do your best on that. Like I say, I understand there is no explanation in the text. So if you want to try and answer it, with words, with logic, to solve some sentences. Maybe you don't feel you can do it without calculating. in that case, explain that and explain what calculations you would do. All right. I guess that should be it for today. Then we'll wrap this up tomorrow. And then we'll also take a look at some of the ways that we can look at data without doing a whole bunch of calculations. All right. Well, we'll talk to you more then. Bye.